Hello everyone, so in this video today we're going to learn how to calculate the voltage drop across a resistor in a circuit. So let's start off with an example. So we have a circuit here with 3 separate resistors and a voltage source of 30 volts. So since we have 3 resistors in series, all we have to do is add up their resistance values to calculate the total resistance. So the total resistance would just be 5 plus 2 plus 7, which is going to be 10 ohms. And now let's use Ohm's law to calculate the current flowing throughout the resistor. So solving for I, we get voltage divided by the total resistance. So we just plug in 30 volts divided by 10 ohms, which is going to be 3 amps. So we have 3 amps flowing throughout the resistor, or throughout the circuit rather, and this current that we found here is going to be constant no matter what point it is at in the circuit. So we just take that current and multiply it by each of these individual resistors to calculate the voltage drop. So here's what I mean. So say for example we want to calculate the voltage drop of resistor 1, the 3 ohm resistor here. We would just use the formula V1 equals I R1, and we know that I is 3 amps, and we multiply it by the resistance value of R1, so that would be 3 ohms, and if we solve that we'll get 9 volts. And we basically repeat the process for all of the other resistors. So let's do V2 is equal to I R2. So once again, the current is 3 amps and the resistance is 2 ohms. And multiplying that, we get 6 volts. So we have 9 volts and 6 volts so far. And now solving for V3, it's going to be 3 amps times the resistance value of R3, which is 5 ohms, which is going to give us 15 volts. So now you're going to notice something pretty interesting. So if we add up the voltage drops across all 3 of these resistors, we're going to end up with 30 volts, which aligns with what we had up here as our voltage source, which makes sense because this basically describes the law of conservation of energy, because energy is neither created nor destroyed, which in this case all the energy has been used up by the resistor, so the voltage drop, the sum of all the voltage drop, will equal the voltage source. So that makes sense there. And that's basically how voltage drops work in a nutshell. But for the sake of this video, let's try out some more problems. Okay, so once again we're dealing with another similar circuit here. So we have a 24 volt source hooked up to a circuit with 3 resistors. So let's start off by finding the total resistance. So RT is just going to be the sum of R1, R2, and R3, which will be 12 ohms. So once we have that, let's use Ohm's law again to find the current flowing throughout the circuit. So it's going to be I equals V RT, and we have 24 volts divided by 12 ohms, which is going to be 2 amps of current. So as this current is flowing through each of these resistors, it gets multiplied by the resistance value of each resistors. So let's do the same procedure we did earlier. So it's the V1 IR1, which is 2 amps. I'm just going to leave out the units for simplicity, times R1, which is also 2, so that's going to give us 4 volts. And now let's go into V2, so it's going to be IR2, plugging in what we have. Current is 2 amps, and R2 is 4 ohms, which will be 8 volts. And now we have V3, which is IR3, so hopefully you guys are beginning to notice a pattern that current is constant in all of these instances for the resistors, in series circuits, of course. So current once again is 2 amps, R3 is 6 ohms, and when you multiply that you'll get 12 volts. So these are all of our voltage drop. And to verify that we are correct, let's add up all of these just to make sure they equal the source voltage. So 4 plus 8 is 12, 12 plus 12 is 24, so our work is indeed correct. It satisfies the law of conservation of energy. So that's basically it for this example. Let's try out another one. Alright, so here's another more challenging example. How would you want to tackle this? So first, let's start by observing the circuit that we have here and notice that we have points A and B, and I forgot to label this, but this is point C. So let's start with points A and B. Going from point A to point B, the voltage goes from 60 volts to 10 volts. So the difference, the electric potential difference, is simply A minus B, which is 60 volts minus 10 volts, giving us 50 volts. So across this resistor R1, we have a voltage drop of 50 volts. So now, with this information, we can calculate the current. So it's going to be I equals V over R. So I is going to be 50 volts that we found over here, divided by the resistance of R1, which is 5 ohms. So this will give us 10 amps of current flowing throughout the circuit. And to find the voltage drop across resistor 2, we simply take the current that we found and multiply it by the resistance value of R2. So let's use Ohm's law. So it will be V equals IR. I is 10 amps, and then the resistance is 20 ohms. So that's going to be 200 volts. So this is our voltage drop across resistor 2. And also, going back to conventional current flows from a high potential to a low potential. So as you notice in this circuit, current is going from 60 volts to 10 volts, and then from point B to point C. So therefore, point C must have a lower electric potential than point B. So to find the electric potential at point C, we simply take the electric potential at points B, which I'll label VB, and then subtracting the 200 volts that we found as being the voltage drop across resistor 2, because that's the path that current has to flow through to go from points B to C. So it'll experience that voltage drop, the reduction in electric potential. So it's going to be, so VC is going to be VB minus 200 volts. So plugging in what we have for VB, it's going to be 10 volts minus 200 volts. So the electric potential at point C is negative 190 volts, which is valid because negative electric potential can't exist in an electrical circuit. So there's our answer right there. And now let's do one last example before we wrap up for this video. Okay, so here's another circuit to test out your knowledge. So how would you go about solving this? Well, let's start off once again by finding the total resistance in the circuit, which we'll just do by adding up all these resistance values. So 8 plus 5 is 13, plus 3 is 16, plus 2 is 18, so we have 18 ohms. Now that we have that, let's calculate the current in the circuit, which is going to be voltage divided by the total resistance, and our voltage is 36 volts. Let's do 36 divided by the total resistance, which is 18. So that's going to give us 2 amps of current flowing through the circuit. So 2A equals I. Now that we have that, keep in mind that current is constant throughout a series circuit. So we're just going to take this 2 amps and treat it like a factor being multiplied by the individual resistance value. So let's start by finding the voltage drop across R1. So V1 is equal to IR1, and plugging in what we have, it's going to be 2 amps times the value of R1, which is 2 ohms. So that's going to be 4 volts. So there's our voltage drop for R1. V2 is going to be IR2, which is 2 amps times 3 ohms, which will give us 6 volts. V3 is the current times R3, so that'll be 2 amps times 5 ohms, which will be 10 volts. And lastly, we have V4, so that's going to be the current times R4, so it will be 2 times 8 ohms, which will be 16 volts. And lastly, like always, to double check our answer, we just want to take the sum of all these individual voltage drops and see if they match our voltage source for the circuit. If it does, then it means our answer is correct. So 4 plus 6 is 10, 10 plus 10 is 20, plus another 16 is 36 volts. So our answer is indeed correct. So yeah, that's basically how voltage drops work. So whenever you're dealing with solving for the voltage drop in a circuit, you simply just want to apply what you know about Ohm's law and then find the equivalent resistance, and once you have that, you can find the current flowing throughout the circuit, and once you have the current, everything else is pretty smooth sailing from there. You just take the current and multiply it by the resistance value of any given resistor, and that's going to be the voltage drop for that resistor. So for instance, over here we did 2 amps times 2 ohms, so we have 4 volts of voltage drop across R1, and then R2 we have 6 volts of voltage drop, and so on. So hopefully that made sense for you guys in this video. Thank you for watching, and if you enjoyed the video, make sure to leave a like and subscribe, and stay tuned for the next one. Have a great day.